So title of the talk, JWT Authentication with AngularJS, but really this is going to be applicable to pretty much any front-end framework that you're working with. What we're really going to be talking about in this talk is like why JWT, like how does it fit into the whole like browser scheme. So a little bit about me. I've been doing full stack development for about 10 years. I didn't know it was called that once upon a time. I just thought it meant like I'll do everything and not say no, but apparently that has a title. Been using JavaScript on the whole stack since 2011. In my last startup, we decided to use Node and Angular because we thought it would help us move quickly, prototype fast, which was true. It was a language learning company, and basically our whole product was a browser application, so this combination helped us move fast. And that's how I've come to be where I am now. And I'm leading the JavaScript team at Stormpath. You saw Randall give a little 3-minute talk early on. We're basically a user identity application for our developers. It's a REST API, so think of us not only as a cloud data store for user data, but also an authentication service. So it's really great because you basically don't have to worry about storing user passwords securely, integrating with all those crazy things like LDAP, Active Directory, Google, Facebook, yada, yada, yada. We basically encapsulate all that for you in a service. And it's free to get started. If you got like a little side project or something you're working on, it takes like 5 minutes to get started with it. So check it out. Quick housekeeping, if you guys want to grab a picture of this. This has actually been working pretty well for sharing the link. So I'll give you guys a second to grab this QR code. Okay. So we're going to cover a lot of ground in here. So just kind of want to give you an overview. I think we've got 40 minutes. Actually, I need to get a timer going. Or there's one on here, actually. Okay. So we're going to recap the scheme that we're all used to, which is like session identifier stored in a cookie. We're going to just briefly revisit the thing that we're all used to, and then kind of talk about why JWTs are happening. We're going to introduce them, and then also talk about access tokens and refresh tokens. There is some overlap between JWT and OAuth, so we're going to talk a bit about that. And the thing that I'm sure you're all the most interested in is like, how do I store these things in the browser? We're going to talk about some of the security trade-offs that you need to think about. We'll get into some Angular specifics, and then if there's time, I have some really deep dive stuff on the right way to do cookies. The point of that part of the talk is to like freak everybody out and like make you run back to your office and like check your application. That part, this is like version 4 of this talk. I've moved it to the end this time to make more room for other stuff. Okay, session identifiers. This is the scheme that we're all used to. User submits a login form, we verify the credentials, create a session, store that ID in a cookie. And in an old school looking fashion, here's what that looks like. Login form, verify the stuff, send back a cookie. Great, all future browser requests are authenticated with this ID. Well, that seems to be going out of fad, especially when you look at all the hype around JWT. So, why is that? Well, aside from it being the cool new thing, there are some legitimate problems with session IDs. And the first one that most people run into is that they're not really like web scale, so to speak, right? Like, now you've got to maintain this pointer between a session ID and the rest of the user data. So now you're incurring like database load for every request. That gets kind of annoying. It's pretty easy to solve that problem. You just basically put that lookup table in an in-memory cache or something that's super fast. You can work around it, but it's a problem to be dealt with. So people have always kind of been looking for something different. And there's a perception that cookies are inherently insecure, which there's truth to that. Like, if you do cookies wrong, it's a disaster, but there's ways to do it right. So I'm going to work on that perception a little bit. So I want to introduce JWTs pretty early on here. Basically, it stands for JSON Web Token, because JSON is the format of the token. But before moving on, I just want to cover some words. So authentication is the part where you're proving who you are. It's that step of asserting like, okay, some credentials are coming in, and I'm asserting that they're for the person who they've been issued to, right? Most common form we're used to is just username and password. You authenticate yourself with those things. But now in like the API-driven world, machine-to-machine communication, we're seeing API keys being used a lot. So that's the authentication part. It's like credentials, give me back something that I can use so I don't have to present those credentials every time. That's what the token is for. It's a way to persist that authorization. I'm sorry, that authentication. The authorization part is what happens after you've authenticated. Authorization is a way of saying, okay, given that you've authenticated as so-and-so, like what do you have access to? So it's like, who are you? What do you have access to? JWTs are simply just a token format. So if we're going to take this idea of exchanging credentials for a token, we have to make some decisions about what that token should look like. And JWT is winning as that format because it's JSON, and everybody loves JSON now for good reasons. And the overlap with OAuth 2 and JWT is that OAuth 2 actually calls itself an authorization framework, and they describe the process of exchanging credentials for tokens. They don't explicitly say what the token format should be, but that's where JWT fills the hole. It's like, okay, you need a token, here's a convenient format for that token. Okay. So, long story short, JWTs are fun. So let's dig in and see what they actually are before we talk about some of the other concerns around them. If you encounter them in the wild, they look just like another ugly string. At first glance, it might be like, how is this different from a session identifier? It just looks like some random crap in a cookie. But it is actually structured. So if you separate it out by period, it's basically 3 base 64 URL encoded strings. The URL encoding is important. If you're like racking your brain trying to figure out why you can't decode something, make sure it's 64 URL encoded. So each of these sections have a name. We got a header, colloquially the body, really it's called the claims body, and then a cryptographic signature. So if you decode the base 64 encoding, then you get down to your JSON. So, as a token that's asserting, authentication, it's got to have some information to describe what has gone on. So the body is where the meat of that is. We're going to talk about that in the next slide. But the header is sort of like this envelope, kind of like information thing that describes the whole token. So one of the features we're going to talk about JWTs is you cryptographically sign them, and the header is telling the system that's going to verify them what the algorithm was that was used to do the signing, so that you know. And then if you've encrypted it, which is an option for JWTs, it tells you information about how to decrypt the body, like what algorithms need to be used. So header is just sort of like the FYI about how to parse this token. But the body is actually the part that has the really juicy stuff in it. So this is where I'm going to spend a decent amount of time. So they call these claims because they're basically making a claim about the person or the system even that authenticated. And as with all RFCs, these common fields are recommended but not required. In practice, you're going to see these fields the most, so I'm going to cover them. You have the issuer field, which is describing who issued this token. So, we're in this world now where a lot of the things we make are like microservices, or our product is actually like a multi-tenant application where multiple customers are like hosting their applications on our platform. So the issuer field is a way of like letting people who are going to look at this token know which application essentially has issued this token. And then you also can see when it expires. Token expiration is a complex thing that we're going to talk more about, but just know that you're supposed to put the expiration time in the token because it helps other people know, should I even consider this thing valid anymore? And the subject is kind of like numero uno. It's telling you who this token represents, like who authenticated. So this can be a pointer to your database system, some user ID, something like that. And again, we're now seeing another OAuth overlap here with scope. So in OAuth 2 land, it being an authorization framework, They describe a whole lot of ceremony around the idea of scope, which is basically just like saying like, this person has authenticated and has access to these things. And scope can differ depending on the authentication attempt. If you've ever integrated with like Google Login or Facebook Login, you've seen this part of OAuth before where you ask for specific scopes, like I want the user's email address or I want like everything, which is always fun when you're presented with that option when you're Facebook logging into something. But this is where the overlap is. But again, it's not prescribed by OAuth. JWTs are just like, hey, we got this token format. We need some way to persist information about that scope that was requested. So you'll end up putting it in the token. So how do we create these things and how do we verify them? If we're going to use these things essentially for authentication, like how do we do that? Well, as we've discussed, to get a token, you have to present some credentials. Traditionally, that's a username and a password. More often these days, we're also seeing API keys being used for like developer services. And they're going to be issued by your server, your authentication service, whatever, however you architect your system. Like you are the one who's issuing these. Your application is granting these tokens, it's giving them out. And as we saw with those signatures before, you're going to sign it with a key, like a strong key that's private to your server. So the only person who can verify that these tokens were sent out by the server is somebody who has access to that same key. These tokens are given to the client. That's why we got to talk about browser security. And the client's going to hold on to them, and then for subsequent requests, until the tokens expire, they can use them to authenticate and be authorized to resources. And all those claims in the body are what helps the verifying service know what the user can do. So on the verification side, this is where it gets super fun and exciting and feels very new. Because it's just a signature validation and an expiration time check, you've now got this stateless authentication mechanism. So as long as your server, wherever in your stack you're verifying authentication tokens, as long as that component has access to that private key, now it can just verify signatures and look at expiration times and be like, yeah, I trust this user. I created this token, and oh yeah, by the way, I put the scope in this token, so I trust this whole thing. So you don't have to go running around to like 3 different layers of databases to figure out like who the user is and what they can do. It's all encoded in this like cryptographically signed token. So this is. So backing up to here. Oh, I'm sorry. Yeah, the question was, what is the signature? So when the tokens are created, there's a hash essentially created of the signature. So with the key, you can verify that the hash was created by that same input. Just kind of like your straightforward crypto hashing kind of stuff. There's tons of libraries out there for these kinds of things. So this, like I was saying, this is where it feels new and exciting. Like, oh my God, it's stateless auth. I don't need a database, right? Like it feels super exciting because I can make decisions locally about who the user is, what they can do, yada yada. And that feels super great, but immediately the question that comes up is like, well, how do I revoke this, right? Like if it's really stateless, then this token is basically valid for as long as it exists. Like that's kind of scary, right? So the OAuth specification described this idea of an access and refresh token, and it's actually super useful. The entire OAuth 2 spec is pretty large and covers a lot of concerns, and it's a good read if you want to go to sleep after lunch. It'll take you like a week to get through it that way, like 1 section per day. But it is actually, I recommend reading it just because it kind of gives you like a high-level overview of things of problems people are trying to solve, and you can kind of pick and choose some abstractions that work. And I'm actually a really big fan of the access token and refresh token scheme. So I want to talk about that one in detail. Basically, the way this works is you're going to create 2 tokens, 2 JWTs, when the user logs in. And you're going to give the client both of them. And the idea here is that your access token is going to have a short expiration time, and the refresh token is going to exist for much longer. Once the access token expires, the client then presents the refresh token to get another access token. Now, the whole point of this scheme is to kind of like give you a little bit of control over how often you do a stateless check and just implicitly trust versus making some longer round trip to assert that this authentication is still true. So, in sum, the paradigm is designed to give you control over the implicit trust trade-off with stateless tokens. So you get to control for how long you'll do implicit trust versus go round trip to a database. Because the idea with refresh token revocation is that's the thing you're going to revoke. If you need to kill this user session, if you need to basically revoke access, you're going to maintain refresh tokens in a database and remove those when you want to remove access. So in this paradigm, the refresh token basically sets the maximum lifetime of the authenticated context. You can sort of think of the refresh token as like the maximum amount of time that this authenticated session can exist. Whereas the authentication token sets, that little bit of wiggle room where if you need to revoke the refresh token, how long can this compromised token be used for? To put this in example, I find it much easier to talk about this whole thing through example. If you're building some super secure banking application, where often there's a requirement that the user gets actually forced out after some period of time, you would set your refresh token to that forced logout time. So if the user's only allowed to have a session for 30 minutes, you would set the refresh token to 30 minutes. And then set your access token to something small, like 5 minutes. So basically as the user's using the application, every 5 minutes you're going to check has the refresh token been revoked? If so, it's game over, we're done. So, that's the super secure side. But then the flip of that is some mobile social app where once the user logs in, they should be logged in forever. And security is probably less of a concern. In this case, you're going to set the refresh token to something insanely large, 4 years, lifetime of the phone. How likely are you to uninstall Chrome, that kind of a thing. And then, how you want to set the access token, again, it varies case by case, but you can do something pretty long there as well. So, but, this all feels nice and exciting to have this stateless check, but what if I want the user to be logged out immediately when I revoke that refresh token? This is something that we're pretty used to being able to do with traditional applications that use a session identifier. And the answer to this one is you got to maintain a blacklist. This feels like introducing the database again to the authentication layer, and there's truth to that. But it's sort of a different process, because rather than maintaining every single session and having to look it up on every request, instead you can just do a really quick check has something been revoked? So if you do need the user to be forced logged out in this scheme, you're going to have to maintain a blacklist of access tokens. So when you're issuing access and refresh tokens, you need to create a pointer between the two. And there is actually a field for that called the JTI field. You just basically put a random ID in the tokens, and then they basically reference each other. So you'll need to maintain those pointers in your database. Is there a question?
So I don't get what happens when an access token expires.
When an access token, that's a good question. When an access token expires, your authentication service should reject it. Just be nope, not valid anymore.
If you have a refresh token, what does that imply?
The refresh token implies that you still have access to get more access tokens. Does that help answer the question?
No.
Okay. How do I describe this? Was there another question? Or?
Maybe the question was, what should the client do if the refresh token expires?
When the refresh token expires, then you basically have to log in again. So it's the whole point of this access and refresh token thing is, from the client's perspective, it's going to keep re-upping its authentication using the refresh token until that refresh token is over. Then it has to present the user with the they have to log in again, basically. But the needle you're controlling between the lifetime of the two, that's an optimization for your security concerns and your backend performance. How often you want to do database checks, how often the client basically has to re-authenticate with you.
I have a question. If the access token expires and I have a refresh token, should I get the access token from the backend services in background without notifying the user?
Yeah, so the question is like, should the user be notified of this? No, this should be totally transparent to the user,
Yeah.
which is where cookies are actually going to be pretty useful when we get to that part of the conversation.
Does the client know when the access token expires?
Shouldn't. Oh, the client, yes.
So you know ahead of time when to send the access refresh token?
Yeah,
Where exactly on the client are these tokens being stored?
that's what we're going to talk about. Yeah. Okay, so back to this whole blacklist scheme. So yeah, if you need the user to be like force logged out, at that point that you're doing that when you're revoking a refresh token, you need to then stuff all the related access tokens in a blacklist so that all requests coming through just double check the blacklist to make sure that it's not in there.
But if you don't mind waiting until the access token expires to log the user out completely, you don't need this blacklist?
Yeah, that's correct. The question is like, if you don't mind waiting, you don't need the blacklist, and that's totally true. Like, I mean, the OAuth spec doesn't even talk anything about blacklists because they assume that you're okay with waiting for it to expire. But I'm putting this in here because this question comes up a lot for us at Stormpath, and so the answer is like this blacklist scheme. So if you're using Redis, it's super simple. You just stuff the access token and the expiration of it in a list. And then when you're checking incoming requests, just do a get on that token. If it exists in the blacklist, reject the request. Otherwise, everything's cool. Okay, so that's a crazy drive-by of like the whole like access token scheme from kind of the client and server perspective. But now we're going to jump into browsers in particular, which present their own set of concerns. Question?
I'll try and
Yeah, you have to, when the access token expires, you have to use the refresh token to get another one. And if that fails, it means the refresh token has been revoked and your whole session is over.
get another access token.
Yes, you get another access token. Yeah, there's an exchange going on there. The question is like, why even use the refresh token scheme if you want to maintain a blacklist? Again, it's just like you're making a trade-off with this whole scheme of wanting to use stateless authentication. But if you get yourself into a situation where you want to use the scheme, but then all of a sudden you're like, well, I need to maintain a blacklist. Performance-wise, it's a lot easier to check a blacklist than maintain a list of session IDs for every single user. So, again, it depends like on your context, but it's going to be somewhere in between these two examples. It's like, how often do you want to check that refresh token hasn't been revoked? Like, how big do you want the window to be in which a compromised access token can be used by an attacker? So for super secure applications, you want to keep it short, but applications where there's not like a whole lot of need for security, you can make it super long. So it really depends on the application, like the needs of the application.
Also, the blacklist, how often do you just dump that and like start blacklisting?
So when you put something in the blacklist, you should have it automatically expire when that access token is no longer valid. So because that expiration time is contained in the token, you can know when you're putting it in your cache layer, just say, hey, expire this when this thing expires. Yeah. All right. So browser. Lots of browser concerns about how to do this securely. This whole scheme is actually like way simpler on mobile because mobile SDKs provide all these ways to like store data in like sandboxes that are protected to just your application. But that's not really the truth with browsers. There's a lot of trade-offs and concerns that we have to deal with. Something you're going to see a lot when you start looking at JWT stuff on the web is people are storing JWTs in local storage, but I'm just going to straight up say don't do that because the local storage area just by the simple virtue of the fact that it's accessible by the JavaScript environment makes you vulnerable to cross-site scripting attacks. We can talk more about what those attacks are, but basically, like, if somebody manages to get malicious code on your site, they can basically steal the authentication tokens. That's a big problem. Cookies are actually a really secure place to store these tokens if you set the HTTP only and secure flags on the cookie when you send them down to the browser. What the HTTP only flag does is prevents that cookie from being accessible from the JavaScript environment. So by doing that, boom, like you've made it like impossible for an XSS attack to steal your cookies. Now, cookies do come with this other really annoying thing, which is Cross-Site-Request-Forgery as an attack vector. How many people know about this one? Okay, I'm gonna talk on that one before I'm done, because this is like a big problem that you have to pay attention if you're gonna use cookies for storage. Something else you're gonna see out there is the authorization header is being used to send the token back to the server. So in the OAuth land, when you start looking at the spec, they say, okay, great, you've got an access token. You're gonna use that to authenticate a request to me. Awesome, I want you to send that to me in the authorization header on the request. So, this is fun, this is different. We can use JavaScript to set headers and all that, but it's really not necessary. And in fact, it kind of like runs into a lot of cross-origin issues when you start dealing with custom headers in JavaScript. But if you're gonna go the cookie route, you don't even need to do this. So it's kind of like, why bother? And cross-domain requests are always gonna be hell no matter what authentication context or scheme you deal with. I'm sure you've run into this before. So just know that whatever you can do to simplify cross-domain situations is gonna help you out. So given all those trade-offs, in my opinion, your mileage may vary. This is what you should do. This is what we do at Stormpath because, if you're using one of our front-end libraries, we want to make sure you're like as secure as possible. So these are the choices that we've made. We do cookies with HTTP only and secure because CSRF protection is easy to get right, but XSS is easy to get wrong. So we just have made the opinionated decision that we want to avoid XSS at all costs and just deal with implementing a CSRF solution. You don't want to use the authorization header because once you're using cookies, it's not really needed. And avoid cross-domain where possible. I know sometimes that's not always possible because your Angular app is hosted on some domain that's different from API service X developed by some team in some other place. But if you have a choice, try to keep things in the same domain. It just makes things a lot simpler, especially when you start dealing with browser compatibility below IE10, and it's just craziness. So what does the authentication logic look like if we're going to use these tokens in cookies? So the situation is the user's logged in. We've sent down an access token and a refresh token, stored them in cookies. On the next request that my Angular app makes to get some data, the server is going to go through these checks. It's going to say, is there an access token cookie? If so, is it valid? Was it signed by me? Is it expired? If those checks are okay, then great, I can allow this request. If they're not, I'm going to be like, all right, hold on. Do you have a refresh token? Okay, cool. I'm going to go try getting a new access token using that refresh token. If that works, happy path, I authenticate the request. On the response, I ship down that new access token. So this is that transparent mechanism we're talking about where the client basically doesn't even really have to deal with managing any authentication stuff. It's just letting the browser do its browser thing of sending cookies and setting cookies. If the refresh token request for a new access token fails, this is game over. The user's logged out, force them to your logout view.
So you transmit the refresh token also in the cookie?
Mm-hmm. So the question is, do you transmit the refresh token? And the answer is yeah. On every request, you're sending along both. So.
The refresh token because it fails once, is that grounds for immediate dismissal, or do you give it another chance?
No, once refresh token, if that refresh token is wrong in any way, it's expired, it's been revoked, the signature doesn't check out, that's done. because that's sort of like, those are the keys to the castle, right? Really, the refresh token is, in a way, replacing that session ID cookie that we're used to using. That's like the point of failure. So if there's something wrong with that, no more. All right. So we've been talking kind of generally about all these things. So let's dive in a little bit into how this stuff looks in Angular. And these are concerns you're going to run into with any single page application, which is, how do I know if the user's logged in? How do I know if they can access a particular view? And how do I know once all that access has been revoked? I'm going to go through each one of these. So is the user logged in? Well, we've used that HTTP only flag so that JavaScript can't touch it. So I can't look at cookies to know if I'm logged in. Alas, this is the one valid argument for putting your tokens in local storage, is that your Angular application can look at them and be like, aha, there's tokens and they're not expired yet, so on and so forth. But is it worth the trade-off of cross-site scripting possibilities? My answer is no, but I'm also like security dude, so there's a trade-off there. If you're going to go the route of using cookies, what this inevitably means is you need to put some kind of route on your server that the application will hit to get information about the current user. We call it /me. I think that came from Facebook once upon a time. Does Facebook still use a /me thing? Does anybody know? Yeah. So you're going to have this async operation, which is annoying, I guess, but in my opinion, it's way more secure. So how do you deal with the fact that I need to do this async thing before knowing if I can even render the application to the user? Well, both ngRoute and UIRouter provide a super convenient way to do this. This is a UIRouter example, but they have this idea of resolves, which is basically on the definition of the view route, you can define a few promises that must be resolved before things go forward and the actual view transition happens. So this is actually pretty straightforward. You'll have some kind of an authentication service that'll have a get user method that's actually returning a promise. It'll do the work of going round trip to that me route and then bringing back the user data. There's also some other really cool things that you can do. You'll see these if you look at our Angular SDK for our product. But we also maintain a user object on the root scope, which is just, yeah, I guess you're not supposed to touch root scope, but whatever, it works. So we maintain a user property there. If it's null, we don't know who the user is yet. So the auth service, if nobody's called it yet to get the user context, or if it's currently waiting on that me route, that this property is null. As soon as the first time that promise is resolved, then we set the context. If the user's not logged in, we set it to false. Otherwise, we populate it with the user's object data. We also broadcast an authenticated event when the user is known. So between these three things, a promise that gets the current user, an awesome root scope hack, and an authenticated event, it kind of covers all the bases of helping all those crazy components you're going to integrate, know, hey, am I logged in or not? And if you need to deal with the case where the user is not logged in, when those resolves fail on those view definitions, both libraries will fire an event, an error event, telling you why the view state couldn't be resolved. So your auth service needs to just give back some information not logged in or whatever as the error properties on these events. Again, if you look at the Stormpath Angular SDK, you can see a lot of this stuff in play. Okay, so the authorization concern, can the user access this view? Well, again, there's another cool argument here for storing the token in local storage, because then we could inspect the scope and see, do they have scope XYZ to access this view, so on and so forth. Pretty cool, but again, that's a trade-off you're making security-wise. Otherwise, the information can just exist off the /me route. You just return that representation of the user that has that information. Question? Oh yeah, so the question is you know, if it's in local storage, it can be modified, but the server can still like verify the hash of the thing to make sure it wasn't modified. Yeah, I mean, those things are all true, but as soon as you start introducing that round trip to the server to verify it, it's sort of like there's been no point in putting it in local storage anyways. So it hasn't actually saved you that round trip to get the information you need. Okay, so an authorization example. Again, we're gonna just like leverage resolves here. So you could chain, if you need to basically assert something about the user before you show a certain view, just chain a promise onto your user getter promise and then make some decision, you know, about like, does the user have XYZ properties? If so, that's how I'm gonna deal with resolving or rejecting this user promise for this view. That's a duplicate slide. Okay, and so the last concern, you know, how do I know when this authentication contact has ended? You know, either because the refresh token expired or it got revoked. So because we're like using APIs, we're making XHR attempts, as soon as you see a 401 response from your API service, that means the tokens have been rejected for some reason. So in this case, you can just fire an unauthenticated event, and then people who need to like do things in your application based on that can respond to that and do something like redirect to the login view. This would be achieved by using an HTTP interceptor in Angular, pretty straightforward stuff. By the way, I learned something super interesting about HTTP interceptors the other day. If you implement all the like response and request interfaces, but forget to pass along the promise that comes in, you can totally muck with other people who file interceptors after you. So be careful about that.
Another question.
Yeah.
How do you check the scope? So you're saying you have this /me root that does something with the scope.
Mhm.
How do you check it? Did you show that in the code?
No, I didn't cover that specifically, but the idea is that the response from the me route will essentially have the scope in it.
Oh, okay.
So,
Okay, so however you want to do it?
yeah. I mean, at that point, you're like going out of bands and not of the token and not really using the token to know, but it's like it's trying to navigate this trade-off of like, do I actually want this thing accessible by JavaScript or not? So, I'm at 38 minutes, which gives me 2 minutes left. This is like serious business time. There's like flow diagrams and there's no cat pictures. I'm actually gonna blow through this XSS stuff because all your cookies belong to me now, and talk about CSRF in the last 2 minutes because this is a super annoying one that's easy to like not know about. It's basically exploiting the fact that HTML tags don't follow the same origin policy. So what does that mean? Well, by example, what it means is if like your user is on some other site and that site's malicious and it puts an image tag in here like this that's making a request to your application that purely relies on just like looking at the information in the cookies to authenticate the request, it's going to do this thing. If you've actually got an API endpoint that takes parameters like this and just says, hey, you've got a session cookie, like cool, you can do that. Well, you know, the browser is going to comply in this situation. It says the request is going to myapp.chrome, so I'm going to send along the cookies from myapp.com. And so your server is just going to like not even know that this request actually came from some other website, which is super scary. So how do you deal with this? Well, if you look at the OWASP security guides, they're going to describe all these crazy things. The synchronizer token pattern is not really useful for single page apps, but the double submit cookie one is. So let's just look at this flow diagram. This is the serious business time part. So if you want to combat CSRF, when you're setting a session cookie on the way down, or access tokens, refresh tokens, whatever, if you're using cookies to store authentication information, you need to do this, which is you're actually going to set another cookie with some random value in it. And then your client, in this case JavaScript, needs to do the annoying thing of creating this custom header when it makes requests to your server and sending that same token in the request. Because attackers on other websites won't be able to forge an attack using JavaScript. Because when you try to set a custom header like this in JavaScript, cross-domain, it's not going to work. It's going to blow up. The browser's going to say, no, I'm actually not allowed to do that because I'm not allowed to talk to that domain. So this is one way you can trigger the browser to enforce that check, is by setting this in the header. So on the server side, it's super simple. You just say like, did I get the same value in a cookie in a header? If so, clearly this is coming from JavaScript running on my domain. This kind of just examples how this looks from the attacker's viewpoint. So if they try to use the same image tag, the cookie will be sent along, the XSRF token cookie will be sent, but this check is going to fail because it's not coming in as a header. And similarly, if they've put some malicious JavaScript in the page and they try to set the header to try to achieve this workaround, the browser is going to straight up just say, no, don't do that. There's a few other things that you can check, but they're kind of just like fallbacks for all that. So if you got the slideshow URL, you can look at the rest of this, ask me questions after, but whew, that's a lot of stuff. Thank you. Don't let him have your cookies. And if you don't want to deal with any of this, just use Stormpath, because I did it all for you. So thanks.